So we're reading the graph from left to right. When we see the word the function, think y values. So if it says the function is increasing, that means the y values are increasing. If it says the function is decreasing, that means the y values are decreasing. When it says over which intervals, that means where is it increasing. So it's asking for the location where the function is increasing. The location are the x values. So this question is asking for which pieces of the domain are the y values increasing. I go ahead and I start from the far left, and I just keep track where it's increasing and decreasing. So I know that on this piece it's increasing, on this piece it's decreasing. It's increasing, decreasing, increasing, decreasing, increasing, right? So then I'm going to mark the parts of the x-axis that I'm interested in. I want increasing. So for this interval, it's increasing. So that means from as far left as I could possibly go, all the way up to here, the function's increasing. So we're going to give the interval from negative infinity to negative 8. And then I look for where does it start increasing again. So here's the bottom of a hill, and it's increasing until the top of the hill. So the x value here is negative 6. The x value here is negative 2. And so it is increasing for all of the x's between negative 6 and negative 2. So decreasing, I skipped that, so here it's increasing again. So we're going from x equals 3. So you're just giving the left x, right x, left x, right x.
Okay.
But you're picking those particular intervals. It's really easy once you've trained your eye where to go. And then the local maxima are going to be the hills. So that means it has the biggest y value for a piece of the graph. It's a local maximum point if it's the highest point for a part of the graph. It's a local minimum point if it has the lowest y value for a part of the graph. But again, be careful with the wording. This particular question says at which x values. So in this particular question, you're going to give the x values for your answers. If it actually asks for the local maxima, if it says what are the local maxima, then you would be giving the y values. Okay, the actual values are the y values. The locations are the x values. So the location is the x values. The actual values are the y values. So the values of the function are the y values. And then sometimes they'll ask for points. In that case, you give the x and the y. That's easy. You don't have to discern between them. So in this problem, the x values are negative 8, negative 2, and 7. So I see that the left arm is falling and the right arm is rising. You need to know about the degree before you can talk about the leading coefficient. So before I can worry about positive and negative leading coefficient, I need to figure out was it even or was it odd?
I would say odd.
Because the ends are going opposite directions.
Yeah.
Okay, so if you look at your table, you'll notice that if they're both going the same direction, it's even.
Right.
And if they're going opposite directions, it's odd. So once you realize that it's odd, then you just pick which one of those two it fits with.
I would say positive.
I agree.
Right?
So for the question, the sign of the leading coefficient, your answer is positive. I made a short little Quizlet set on these facts. If you look at the number of maxes plus the number of mins, sometimes textbooks that I've worked with have called those turning points. So if I'm just going to throw the maxes and mins all into one big pile and call them turning points, the number of turning points can be at most the degree minus 1. Think of a straight line. A straight line has no turning points. So if you get confused, you can recreate this and see the pattern. A parabola has 1 turning point. It has degree 2. A cubic could actually have 2 turning points or no turning points. But the most that it can have, if it's a cubic, it can have at most 2. If it's 4th degree, it can have at most 3. So the number of turning point is at most the degree minus 1. But then if you flip it around, you have to take the number of turning points and add 1 to get your smallest degree. So in this case, I have 1, 2, 3, 4, 5, 6 turning points. So I'm just counting Hill, valley, hill, valley, hill, valley. So it can't have degree 5. Degree 5 can have at most 4 turning points. Degree has to be at least what?
7.
Right. If it were 8, it would have the wrong end behavior, but it actually could also have 9.